Have you ever stopped to ponder what makes up the world around us? What are the building blocks that form everything we see, touch, and interact with? The answer lies in a world so tiny, it's invisible to the naked eye. Welcome to the world of atoms. Imagine a bustling city. The buildings, cars, trees, and people all have their own roles, working together to create the cityscape. Similarly, an atom is like a miniature city, with its own components interacting in harmony. At the heart of this atomic city lies the nucleus, positively charged and incredibly tiny. Despite being less than 1/10,000th the size of the atom, the nucleus holds more than 99.9% of the atom's mass. This is the central hub, the downtown of our atomic city, made up of protons and neutrons. Protons are the positively charged particles, and neutrons, as their name suggests, are neutral. They're held together by a powerful force, the nuclear force, which is much stronger than the electrostatic force that binds the electrons to the nucleus. However, its influence is limited to a very short range, about 1 × 10⁻⁻15 meters. Circling this downtown hub are the electrons, negatively charged particles that form a cloud around the nucleus. These are the commuters, constantly in motion around the city center. The number of protons, or the atomic number, defines the element. The number of neutrons, on the other hand, can vary within atoms of the same element, creating what we call isotopes. Let's take hydrogen as an example. Hydrogen has 3 isotopes: the common hydrogen, deuterium, and tritium, each with a different number of neutrons. The total number of protons and neutrons, or the mass number, is usually slightly different from the mass of the nucleus measured in atomic mass units. Currently, we recognize 118 elements, each with a unique atomic cityscape. Elements with atomic numbers 1 through 98 are naturally occurring, while those with atomic numbers 99 through 118 have only been produced artificially. These atomic cities, or nuclides, are often named after the element and the mass number. For instance, we have lithium-7, uranium-238, and so forth. When we're talking about nuclides of the same element, we generally call them isotopes like uranium-238 and uranium-235. Among these elements, there are 253 stable nuclides and over 3,000 radioisotopes. Most of these radioisotopes, more than 2,400 of them, are artificially produced and not found in nature. So, to summarize this atomic journey, atoms are the tiny building blocks of matter, made up of protons, neutrons, and electrons. Different elements have different numbers of protons and can have different numbers of neutrons, creating isotopes. The world around us is a symphony of these atomic cities, interacting, bonding, and forming the matter that creates our reality. So the next time you look around, remember the bustling atomic cities that make up everything you see.